Hello. Today we're going to go over the AP Classroom Unit 2 Free Question Set B. There are 2 questions in this set, and I'm going to do them as separate videos in case they take too long. So we're going to do this question 1 here. And for this one, no calculator is allowed for this question. All right, if you've not yet read this stuff up here, you can go ahead and read this and then come back and join me, but I'm going to go ahead and move on. So we are given these 2 graphs, the graph of a function f and the graph of its derivative f prime. So the graphs of the function f and its derivative are shown above for x between -1 and 4. For part A, we are to find the average rate of change of a function f over this interval from -1 to 4. And then how many values of x in that interval does the instantaneous rate of change equal the average rate of change over this interval? Let me enlarge this a bit. So there's not enough room here to write our answers, so we'll have to go to another page. All right, so for part A, we want to find the average rate of change. An average rate of change of f is going to be this interval, change in y over change in x. So f of 4 minus f of -1 all over 4 minus -1. Reading our graph, f of 4 off of the f graph, f of 4 is 1. F of -1 is -2. 4 minus a -1, that's 5, and we end up with 3/5. There's your average rate of change, is 3/5. Now the second part of this question then, for how many values of x in the interval -1 to 4 does the instantaneous rate of change of f? All right, instantaneous rate of change of f, that's f prime, that's the derivative. When does f prime equal the average rate of change? So on here, instantaneous rate of change of f, when does this equal 3/5? 3/5 is right about here. So how many times does this instantaneous rate of change equal that 3/5? That would be 1 right about here, so 1. And then a second one right about there, 2. So 2 times. So when does f prime equal 3/5? Instantaneous rate of change equal average rate of change? This is going to occur twice. Okay, and that's part A. Part B says, write the equation for the line tangent to the graph of f at x equals 1. So anytime we write the equation of a tangent line, we're going to set this up. Y minus something equals slope times x minus something. They gave us the x equals 1, so that goes in here. This is the y value on that f function, so this would be f of 1, which if we go back and read the graph, f of 1 is 2. Fill that in. Right here, there's slope, which is f prime at 1. We'll go back to the graph. F prime at 1. F prime at 1. It's the y value on this graph. Don't give me slope off of this graph. The y value on this graph is -2. F prime at 1 is -2. And that's it. There's your tangent line right there. Part C. Sorry. All right, the scratch paper is getting in the way here. Part C. For each of the limit as x approaches 2, f of x minus f of 2 over x minus 2, and the limit as x approaches 3 of f of x minus f of 3 over x minus 3. Find the value or give a reason why it does not exist. So I'm going to go ahead and write those two down here, and then we can talk about them. So we need to find the limit as x approaches 2 of f of x minus f of 2 all over x minus 2. You should recognize this standard difference quotient. This standard difference quotient is exactly f prime at 2. That's a derivative at that x value at 2. So we look back at our graphs. F prime at 2, right here, f prime, we're reading the f prime graph at 2 that has a y value or a function value of 1. So f prime at 2 is equal to 1. F prime at 2 is equal to 1. And that was it. Just find that value. Okay? Or now we have to find a reason that does not exist. Well, guess what? This next one's not going to exist. Usually if they ask you something like this, you're going to get one that does exist and one that doesn't. They want to see if you can tell the difference. So if we look at this one, this would be the limit as x approaches 3, f of x minus f of 3 all over x minus 3. That is f prime at 3. Okay, so a couple of things, two ways to look at this. If we look at the f prime graph, f prime of 3 does not exist. There is no y value plotted here when x is equal to 3. So right there, we can say that f prime of 3 does not exist. Okay, now you can also tell by looking at this graph. The graph of f at x equals 3, f prime, we have a corner going on here. So f, the slope from the left-hand side does not equal the slope from the right-hand side. So f prime from the left side of 3 does not equal f prime, the slope from the right side of 3. This does not exist. You can say because f of x has a corner at x equals 3. So f of x is not differentiable at x equals 3. That's one way of writing it. Another way to write that is you could say f prime from the left side of 3 does not equal f prime from the right side of 3. Either one of those are acceptable. Okay? The next part, that was part C. Let's move on and take a look at D. Let G be the function defined by g of x equals, e to the x times f of x. Find g prime of 0. Again, I'm going to have to go to another piece of paper to write this down. Let's go here, D, and again, g of x was e to the x times f of x. We want to find g prime of 0. All right, let's find the derivative here. G prime of x, we have a product rule going on. First, second. So first, e to the x times the derivative of the second, f prime of x, plus the second, f of x, times the derivative of the first, e to the x. And then we need to find g prime of 0. So g prime of 0 is e to the 0 times f prime of 0 plus f of 0 times e to the 0. Simplifying here, e to the 0 is 1 times, now we need f prime of 0. We're going to have to go back to the graph. F prime of 0, f prime of 0 is 1 plus, and then here we'll need f of 0. f of 0, that's 3, times, and e to the 0 is 1. We end up with 1 plus 3, which is 4. So g prime of 0 is equal to 4. Okay? All right, now let's take a look at scoring here. On A, you get an answer for the 3/5. You get a point for this 3/5, so plus 1 here, and plus 1 for saying that it occurs two times. Now, had you come up with a different answer here for this 3/5, then if this answer was different, but it matched what this answer came up with, you would not get this point, but you would get that one. Again, they don't follow through with double jeopardy. Okay, so part B, it's only 1 point for the equation of that tangent line, and it does not have to be in this form. It can be any form. You get 1 point for the answer for the equation of the line. Sometimes you'll get a point for that slope here, and another point for that point. It really kind of depends on how many points they have to spread out over the problem. Part C, you'll get 1 point for this answer here for the limit as x approaches 2 of f of x minus f of 2 all over x minus 2. And you will get 1 point for this one, answer with reason. So you need to say it does not exist, and you have to explain why either of those answers is acceptable. Okay, last one, part D. This one gives us plus 1 for the derivative. So getting the derivative right here gives you a plus 1. And you get a plus 1 for substituting in that point, or substituting in x equals 0. You actually don't have to go all the way down to 4. You'd be acceptable if you stopped right here at 1 times 1 plus 3 times 1. They don't make you simplify numerical answers. And so we end up with 7 points for this problem. All right, that's the end for, this is Unit 2, Free Response Question Set B. Question number 1. There is a question number 2, and that will be on a separate video.